I want to spend the next few minutes going over the video you watched on 9.3. For those of you that took notes and those of you that did not take notes, you need to be writing these examples down and following along. Please ask the sub to hit pause if you have any clarifying questions or if you need anything to be explained further. The first problem I want to look at is a problem involving not only quadratics, but also fractions. So if you took the notes, you'll know that when you're asked to solve a problem like this, the very first thing you want to do is get rid of the fractions. You also know that when you're asked to solve, you have to check your domain. Now keep in mind, when we learned chapter 7, you cannot have a 0 in the bottom of either of these fractions. If you end up dividing by 0, there's no solution. So the first thing you've got to do is make sure that you check your domain. So I'm going to start right here. What number could I plug in for x that would make the bottom of this fraction 0? It'd be a 1, I'm hoping is what you said. What number could I plug in for x here that would make the bottom of this fraction 0? It would be 0. So our domain then is the set of all x's such that x cannot be a 1 or a 0. Now, keeping that in mind, we're going to go ahead and solve this, but if we get a 1 or a 0, it will not count as a solution because it would make one of the bottoms of this 0. Now, the second thing that we need to do once we've identified our domain is get rid of the fractions like we talked about. And to get rid of the fractions, we're going to actually multiply by our LCD. In this case, we've got two fractions that we're going to look at to determine what our LCD is. We've got this fraction right here with the denominator of x minus 1. We've got this fraction right here with the denominator of x. So we've got a monomial and a polynomial. When you have a monomial and a polynomial, you're going to end up using both of them. And the LCD, if you remember from chapter 7, in this particular case is going to be x and x minus 1. We're going to use both. Now, to begin our process to get rid of these fractions, we're going to multiply in the top so we can cancel what's in the bottom. We're going to multiply by the LCD of x, x minus 1, and we're actually going to multiply all three of these fractions, including the 9, by the x, x minus 1. So over here, the x minus 1 is going to cancel. In this middle term, nothing's going to cancel because there wasn't a fraction, and that's fine. And in this third fraction, just the x's are going to cancel. And it's going to leave us this pretty messy problem, but at least there's no fractions. I'm going to flip to the next slide, and we're going to finish solving this. All right, so this was the polynomial we were left with. So now what we're going to do is we're going to simplify this and solve it like normal. My first step is going to be to go ahead and distribute, giving me 4x plus 9x squared minus 9x equals 7x plus 7. Now when I look at this, I see that there's an x squared. So the minute I see that there's an x squared, I know that I'm going to need to set it equal to 0 to factor it or to use quadratic formula. So that's kind of where I'm going to head. The 9x squared is by itself. I'm going to pull him to the front. Remember, we want this in standard form. Now I'm going to put my x's together. I've got an x here, and an x here. Let's start with 4x and negative 9x. They're on the same side of the equal sign, so I am not going to do the opposite. I'm just going to add them. So 4x take away 9x's is negative 5x. And then I'm going to add this 7x over the equal sign, and what that's going to do is it's going to give me a positive 2x. Lastly, I'm going to bring over this positive 7, and since I'm going over the equal sign, I'm going to subtract it, so it's negative 7. Now I could factor this, or I could use quadratic formula. I'm going to go ahead and use quadratic formula. So it's going to be negative b plus or minus square root of b squared minus 4ac all divided by 2a, or 2 times 9. Once again, we're going to pause for a second. I'm going to go to the next slide so we can finish this. All right, so now I've plugged in my ABC, and the first thing I'm going to do is I'm going to simplify that radical. For my discriminant, I end up getting 256, which is nice because 256 is a perfect square. Square root of 256 is 16. So one of my answers is negative 2 plus 16, or 14 over 18. We're going to reduce that in a second. My other answer is negative 2 minus 16, or negative 18 over 18. Now the negative 18 over 18 becomes negative 1. The 14 over 8 we're going to have to reduce. It looks like I can divide both of those by a 2. So I'm going to get 7/9. So my solution is -1 and 7/9. If you remember our domain, it was +1 and 0. So neither one of these is a +1 or a 0, meaning both of them are possible solutions. For the second type of problem that we're looking at, we're going to be looking at substitution. So when you look at a problem like this, you notice a few things. It looks like it's in standard form. I've got a squared term plus some sort of a middle term plus a constant. The one thing I do notice is the k plus 3's are quantities, but they're the same quantity. So I'm thinking to myself, man, wouldn't this problem be a lot easier to solve if instead of k plus 3, it was just an x? So in other words, what I'm saying is, if I could make my x be k plus 3 and substitute it in, instead of k plus 3 squared, I'd have x squared. Instead of 5 times k plus 3, I'd have 5 times x. This problem looks a lot more simple to solve than this problem. So I'm going to use this equation right down here, x equals k plus 3, to substitute every k plus 3 for x. Now what that's going to do is it's going to make this problem a lot simpler to solve. In fact, I can solve this by factoring. What multiplies to 6 and adds to 5? And I end up getting that x is a -3 if I subtract the second guy over, and a -2 if I subtract the first guy over. So -3 from here, -2 from here. Now the problem is, I didn't ask you to solve for x. This is what x equals. I asked you to solve the equation, and the equation had a k in it. This is what x equals, not what k equals. So let's go to the next slide, and I'll show you how you can actually figure out what k equals, not x. So if you remember, x equals k plus 3 was the equation that we used for substitution. And what we got was that x equals -3, -2. Remember, I didn't ask you to solve for x. I actually asked you to solve for k. So what I'm going to do is I'm going to take the original substitution equation, x equals k plus 3, and instead of x, I'm going to plug in what I know x is. X is -2. So -2 equals k plus 3, and x could also be -3 equals k plus 3. What this is going to enable me to do is to subtract that 3 over and determine what k is. I got k is -5, and I got k is -6. Now that is my final answer. So this is the last type of problem we're going to look at today. Once again, we've got an equation I need you to solve for m. It looks like it's got a fraction, but the fraction is stuck underneath a square root. And I also don't see anything in common like the k plus 3 on our last problem that's repeated enough that indicates we need to do anything like substitution. So the first thing I think of is, well, let's get rid of that square root. I can't do anything to all of this stuff under the square root until I get rid of the square root. And the way we get rid of a square root is we square it. If I square the right side, though, I also have to square the left side. And what that's going to do is it's going to remove that square root, but it's going to give me an m squared on one side. So it gives us a quadratic. The next thing I see is I need to multiply by 5, and that's going to get rid of the fraction. Remember, we always multiply in top, so we can cancel what's in bottom. Now this looks like a problem I can handle. The first thing I notice is I want to put it in standard form. I'm going to add over the 13m. I'm going to subtract over the 6. Now I've got it set equal to 0 in standard form, and I can solve this using quadratic formula, which I'm going to do on the next slide. All right, guys, here we go. So let's do quadratic formula. We've got -b plus or minus square root of b squared minus 4 times a times c all over 2 times a, or 2 times 5, which in this case is 10. First thing you want to do is you want to simplify this square root. And if you simplify the square root, 169 minus 4 times 5 times -6 ends up being 649, which is a pretty nasty square root. It is not perfect, but it sure looks like it could be reduced. So let's try to take that 649. So what I did in my calculator is I tried to divide by 3, I tried to divide by 5, I tried to divide by 7, by 9. Finally, Mr. Laughlin and I figured out it is divisible by 11, but it gets you a 59, which is a prime. meaning there are no pairs, meaning this 649 is not actually able to reduce, and this actually is your final solution. There is no reducing of 649. So you're done.